American Chemistry Council, and he will be talking about too valuable to waste, rethinking used plastics, and very much like to thank Steve for his big support for 2 years now of Plasticity. Thank you, Steve.
So excellent, only 3 more speakers till lunch. And so for those of you who's sitting in the sunny side of the room, condolences. It's like a Men in Black convention over here, and then the rest of you are sort of sitting back cool with sweaters on and kind of, all right. Hopefully my luck is better with this than other speakers. So I'm Steve Russell with the American Chemistry Council. We represent the companies as a national trade association that manufacture plastic resin pellets. So we sell them. We're the upstream supplier of the raw material that the companies that generally belong to the Society of the Plastics Industry, SPI, convert into things that we all use every day, from car parts to Ziploc bags to medical devices to building insulation, et cetera. So that's kind of where we sit in the supply chain. And so as you might guess from my employer, I'm a huge fan of plastic. Many of us here are, and what's not to like, right? Durable, affordable, endlessly adaptable. It's got cool engineers making cool things that solve big problems. Shampoo bottles don't break in the shower anymore. Cars and trucks are lighter and therefore more energy efficient. Our homes are almost perfectly insulated thanks to plastic. And in fact, some of the recent innovations that are sparking a lot of attention really are on the cutting edge. Medicine that can be delivered through plastic to just the right place. Lifelike prosthetic devices. Smart packaging that keeps food fresh longer and even tells us when the food's about to go bad so we can manage the amount of food we purchase better. Ultralight polymer composite materials that are keeping aircrafts up in the sky with less weight, using less fuel. Things that, by the way, since nobody's mentioned it yet today, even spicing up the World Cup, right, with a NASA-engineered brassoucha, right, soccer ball that I will say is made of 5 different layers of polyurethane. You gotta love polyurethane for a straight shot, right? So, plastics do great things. Plastics come from energy, but also can save a lot of energy. And what I want to talk about here is how we can manage the use of plastics in a way that maximizes our energy, the energy benefits that we get from plastic, while minimizing the waste and the materials that get sent to landfill, a future that none of us want, and it represents a tremendous wasted opportunity. So that's why our organization and others are really digging more deeply into ways to make the 4 Rs a part of our everyday experience, both in business and as individuals in our communities. So starting with reduction, plastics are all about source reduction. They allow us to do more with less. We think about reduction in terms of individual utilization, but think about plastics also in terms of how much other material plastics help us avoid. Life cycle assessment data done, assessment project done in Europe and then replicated in the US has showed that if we replace plastic packaging with alternative materials, we would dramatically increase the amount of packaging material that we use. Alternatives to plastic packaging would require 4.5 times more material by weight and increase the overall amount of packaging used by nearly 110 billion pounds. That would increase the waste generation by 22%, equaling the weight of, get this, 169,000 Boeing 747 jumbo jets. It's a lot of weight. It's a lot of material that if we decided we're not going to use plastic anymore in packaging, we're going to use alternative materials, that's what we'd end up with. So the results are really striking. These are big numbers with the potential to have big savings. And in a world that throws away 40% of our food from farm to fork, we really can't afford to use the wrong material to package our food. There are tremendous implications in terms of hunger, poverty alleviation, and access to fresh, nutritious food that we have to think about when we choose the right packaging material for the right application. So reducing food waste is something that our members are thinking about really deeply when we choose the kind of packaging material that's put into the market for particular end uses. But this kind of thinking is not just in packaging. So I want to diverge for a minute into other materials that we don't think about when we think too much about waste. But it's not just packaging, it's automotive. OEMs are increasingly turning to plastics as a way to take weight out of cars meaning they use less fuel, meaning there are fewer greenhouse gas emissions. And it's a great way to help them meet CAFE standards. So cars today are made up by volume of 50% plastics, and that 50% volume requires only 10% of the weight of the car. It's an amazing weight savings that plastics provide. It's from the bumper, the airbags, the seat belt, the cushions, the fabric, the carpet, increasingly the fuel tank, also made of plastic. The next wave of materials that's set to sort of take over the automotive space is carbon fiber reinforced plastics and composite polymers. Used to be space-age sort of materials for Formula One race cars, showing up now in everything from the new BMW electric car all the way to the Dodge Stingray and the new smart car. You know, really cool materials that are going from the racetrack to our driveways. We are all able to experience the benefits of some of these new materials. Not just homes, but in the built environment. Modern plastic foam insulation can help houses and buildings achieve almost net zero just by themselves energy consumption. The R value of plastic foam insulation is exceeded by no other form of insulation, providing a continuous barrier for air in and out, also providing structural support at the same time, and other building benefits in the built environment. So we talk a lot about source reduction and reusing the second R is something that consumers do more than material suppliers. You know, it's up to us to individually make choices to reuse, but there again, plastic products are showing up to help us reuse as well, whether it's grocery bags or food and beverage containers or water bottles. Plastics are part of that as well. So the third R, recycling. Ron Gonen talked a little bit about some of the challenges. I'll talk a little bit more about them as well. Plastics, let's stipulate that plastic recycling is nowhere near it needs to be, right? And there are a couple reasons for that. One, plastics are relatively newer materials. Recycling of them started later. Communities that invested in recycling infrastructure didn't originally invest in the material to do it, so it was an additional investment required. As Ron said earlier, not just one kind of plastic, like there's one kind of aluminum and a couple kinds of cardboard. This stuff is important to separate. So there are some really significant challenges in getting it done well. And unfortunately, since everything that's done at a community level with different standards from different communities, different people being told different things about what is and isn't recyclable, there's confusion, and so people throw up their hands, right? So we think there's opportunity in working with different stakeholders in the recycling space to help them do a better job. And so our role has been to partner with communities, with NGOs, with folks actually doing the recycling to give them both technical support, moral support, leveraging their communications and outreach where we can. So for example, today, almost all Americans have access either curbside or through community drop-off to bottle recycling. There are more than 18,000 places across the United States to drop off film and bags. So these things that MRFs don't want, right? Because they come up the system. Different infrastructure suggestions are being made for how to keep that material out of the MRF and yet get it recycled. Today, more than 30% of plastic bottles get recycled. That's just barely below the rate for glass, so they're making inroads. One real success story has been the rate of increase in recycling for non-bottle rigid containers. So it's everything that doesn't have a neck on it, so a tub, yogurt cup, butter tub, those kinds of things, and toys, rigid containers, and rigid plastics. New York City was a real leader in expanding access to rigid container recycling, and as a result, more than 1 billion pounds were collected in 2012, and that is remarkable, not just because of the number, but because it's a tripling of the rate from just 2007. So the rate of increase for recycling of these rigid containers is growing rapidly. So to help get the word out, we're working with others and leveraging their capabilities and expertise. One of the organizations is sorry, I'm trying to move a little quickly, Doug, and it's getting ahead of myself. One of the organizations is the Sustainable Packaging Coalition, and Catherine and her folks have just done an amazing job helping sort through the confusion and communicate more clearly. And we've been working with them on the How to Recycle label. That label is already having tremendous uptake in the marketplace. Costco, General Mills, Microsoft, companies you may have heard of, are adopting that for their film packaging, and it's thanks to the SPC and their hard work in getting that there, and we've been happy to help with that. There's been another coalition formed to establish the infrastructure to get the film and bags that are hard to recycle at a MRF out of that stream and get them recycled. And so recyclers, resin suppliers, and converters are working together to help retail facilities establish points of collection for both the film that comes with the shipment of merchandise to the shopping mall, but also consumers that can bring their film and bags back to the mall to use reverse distribution of those shippers to get the film where it needs to go. So things like that we think are beginning to make the kinds of inroads that need to be made to really move the needle. So I would mention also, Stefan showed the slide earlier of the I Want to Be Recycled, the picture of the bench. That was actually an initiative of Keep America Beautiful, and one that we've been supporting for a long time and getting that going. I urge you to go to iwantoberecycled.org, like them on Facebook, help share their message. The more people support that they get, the more time that the Ad Council provides, and the more that message will get out. So you can do your part by helping them go on, like it, share it. Okay, so the truth is, no matter how hard we work, we all want to do our best and give people the resources they need. $100 million is a great start. Good job. The truth is, we probably aren't going to get to 100% recycling for plastics. Not likely to happen. So one of the things that we've been focusing on is how to create the impression of value in used materials so that people understand that we need to do something other than wasting that value by burying it in a landfill. And so that takes us to the fourth R, which is recovery. Now, bear with me. A lot of folks have different impressions about recovery and what it means. So there's traditional waste energy. I'm going to spend a few minutes on that. Waste energy, combust municipal solid waste, capture the steam, convert it to electricity. How much value is there? Well, according to the scientists at Columbia University, if all non-recycled plastics, just the non-recycled part, were sent to waste energy, we could power 5.7 million homes for a year. It's a lot of energy being buried. Or if we diverted all municipal solid waste to waste energy, we could produce enough electricity for 14 million homes. Of course, the gain's not as great because plastics are so energy rich. But still, 14 million homes. And what are we doing? We're burying that resource. So as a nation, we need to think more about how it is we manage what we use and what we throw away, and what decisions we make to get the right material to the right place. Other places seem to be doing a better job of that. Japan, with 40% fewer people, converts more than twice the amount of material to energy that we do. In Europe, as an average, there are more than 4 times as many waste-to-energy facilities as there are here in the United States. Germany, which uses a very aggressive approach to combining recycling and energy recovery, get this, landfills only 1% of their municipal solid waste. It's really a remarkable combination of thinking through strategically how you get to that kind of outcome. I know folks have had some concerns about energy recovery based on emissions. Modern waste energy today has been evaluated by EPA, and EPA concluded that waste energy facilities produce less environmental impact than almost any other source of electricity. Yes, we need to move to renewable energy from non-carbon-based sources. Until we get there, there's a great role for energy recovery to supplement that. So, beyond traditional combustion, what are we going to do with all that waste that's out there? Well, the good news is there are several emerging technologies coming to the rescue that we think are right on the cusp of being in your backyard or neighborhood very soon, and we hope you welcome them because they have a tremendous potential to transform how we think about waste and the value we get from it. One of those is through a technology called pyrolysis, or plastics, which converts used plastics to oil. One of the companies that's in the pyrolysis business has said they believe they can convert 50 tons of plastic waste into 26,000 gallons of oil per day. That's a lot of oil captured from our landfill. And if all the non-recycled plastics in the U.S. were converted using this pyrolysis technology, we could create enough fuel to transport 9 million cars for a year. I mean, that's just a tremendous amount of fuel that we are currently wasting. Plastics also can be converted using a different technology called gasification. gasification. You'll hear a little bit more about that later today from another one of our speakers. It's been used successfully in Japan, South Korea, and other places for several decades. Hasn't until now caught on widely in the U.S. However, in 2013 alone, we've identified 21 companies that were in the process of conducting demonstration facilities or in piloting their work, and 17 have commercial scale facilities in some stage of financing. So it's a technology that we believe we're going to see quite a bit of. Another one that's maybe not as sexy, especially when you think about what it is something called engineered solid fuel. Now the companies, this is a very cool idea. So plastics that don't get recycled, after the MRF separates them, there's always a little bit left over. One company's been experimenting with that and creating a blend of non-recycled plastic trailings to create fuel, putting it through something like either a pasta maker or a meat grinder, right? And so pellets come out the other end, and those pellets are used as fuel in a cement kiln. Free, or virtually free, to the purchaser of the fuel. Tremendous value, because we're not mining coal to fuel a cement kiln plant, and keeping the plastic out of landfill. A tremendous solution that we think is poised to take off really well. And I don't know if you read about a week ago, there's also sort of less technical and more partnership-y things going on. Recently, Republic Industries, the community of Citrus Hill, California, which is apparently near Sacramento, I think it's a Sacramento suburb, Dow Chemical and Agilix have partnered together on something called the Energy Bag. If you haven't heard about this, Google it to go find out. It's a very cool partnership. The community is being asked to put your waste in the waste, put your recycling in the recycling, and for plastics that don't get recycled in that community, put them in a purple bag that Dow is supplying. Republic will haul the bag, Agilix will take it, convert it to energy, and based on the pilot, we think that might be a really cool model for other communities. So a lot of thinking is going on in that space, and congratulations to them for taking up the challenge that Steve Rochlin gave us earlier today about active engagement. So the technology exists to do creative things with plastics and keeping them out of the landfill. What do we need to do to get from here to there? Well, the first thing we need to do is talk about it. It has been a bit of a third rail among environmental community members, people who think very carefully about waste. But we think it's time that the technology has evolved, the processes are new, the emissions have been documented, and the partners are ready, and financing is in place. We think that time is about to come, and so we really welcome opportunities to have people who are thinking deeply about these things, like here today, engage in a dialogue on that. So we would really welcome your feedback, what you think, what your experiences are, and what we might need to think about as we support that work going forward. I want to wrap up quickly with one other thing. We talk a lot about keeping plastics out of the ocean, and so I couldn't let the opportunity go to talk a little bit about what the American Chemistry Council and the plastics makers are doing. You'll see in your meeting materials in the back a document called a Declaration of the Plastics Industry. In March of 2011, NOAA and UNEP hosted something called the 5th International Marine Debris Conference, and it brought together a bunch of folks who care deeply about the ocean, NGOs, government folks, to see if we could begin to agree on things and to stimulate action. And in advance of that, our organization thought, well, you know, we really do have a role to play, and it's time for us, we've been doing things for years, to pull those things together and to see if we can get other groups to join us in those efforts. So at that time, we launched what we called the Global Declaration on Solutions to Marine Litter, and we invited other trade associations and plastics manufacturers from around the globe to join us. Last week, we announced an update to our original commitment report, and I'm pleased to say that we now have over 60 associations from 34 countries around the world that have signed on, and they have made 185 different commitments to take action to reduce marine debris. Those range from recycling projects, beach cleanup, education, community outreach, pellet stewardship, and engaging in partnerships with their local governments. We also committed to be transparent in reporting regularly on the progress and to being accountable for the work that's being done. So the progress report that you see in your packet is the most recent installment of who's doing what where. You all come from a lot of different places. Would encourage you to look around, see what's going on in your state, community, country, and we'd welcome your feedback for how we can take that declaration to the next step. So we've covered a lot of ground. I've tried to do it in a few minutes. Yeah, so we've saved a few minutes. If there's questions, I'd be happy to take them.
Actually, Steve, this isn't a question, but so much to follow on about your partnership with our organization, SPC. You failed to tell the more important part, that there are scholarship dollars available to help companies who want to recycle film, LDPE, et cetera. We can help you. Actually, ACC is helping offset the cost of carrying the label and designing the artwork for your package. So thanks so much, Steve.
Thank you, Catherine. Thanks. I can't hear you yet. Wait till the...
You've addressed the issues of concern with regards to emissions. Are there any additional concerns with regards to the remaining material post conversion to energy, the remnant sludge or ash or whatever it is? Is there any concern about toxicity of that?
I would direct you to the people who are actually doing it. From what we understand, it is not an EPA-regulated hazardous waste. It goes directly to landfill. There's some folks here today who I can point you to that are working on those technologies in both gasification and pyrolysis, and they can give you the details on what's left over at the end of the process. Great. Thanks, Doug.